Hello and welcome back to Probability and Statistics. In this video, we're going to discuss covariance and correlation. So our learning goals is to understand the meaning of covariance and correlation and be able to compute the covariance and the correlation of two random variables. So let's start with covariance. So covariance is a quantitative measure of the extent to which the deviation of one variable from its mean matches the deviation of the other from its mean. So it is mathematically relationship that is defined as, so covariance of x and y is equals to expected value of x minus expected value of x multiplied by y minus expected value of y. However, we can rewrite the above equation to get an equivalent equation. So we will use this formula, simple formula. So we have covariance given x and y is equals to the expected value of x multiplied by y minus expected value of y multiplied by expected value of x. So to explain further, here's an example. So suppose that we have 5 students and we asked their grades on 2 statistics classes. We have Stat 1 and Stat 2. So here we have student A, B, C, D, and E. So their grade in Stat 1 is listed here and their grade in Stat 2 is also listed here. So what we want to know is, our Stat 1 and Stat 2 grades are related according to this data. And how are they related? So here we will find the covariance of our given data. So we have our formula covariance given x and y is equals to expected value of x multiplied by y minus expected value of y multiplied by expected value of x. So what we're going to need to do is find first the expected value of x multiplied by y. So what we're going to need to do is first multiply x to y. So we will multiply, we'll first assign variables to our data. So for stat 1 grade, we will denote that as x, and stat 2 we will denote that as y. So what we're going to need to do is get first the, we will multiply first the x and y to get the expected value of x, y. So here we multiplied x by y, so we get 95 multiplied by 70, we have 6,650. 77.5 multiplied by 55, we have 4,262.5, so and so and so forth. So to get the expected value, expected value is also known as mean or the average of the data. So here we have the average or the expected value of our x. We have also the expected value of our y, 64.5, and we have the expected value of our x multiplied by y. So this will be now our expected value of x multiplied by y. So we have 5557.5. So we assign that here, and then minus, we'll get the expected value of y. So we get the average of our y variable, and that will be our expected value for y, and multiplied it by expected value of x, which is our average of x variable in our data. So we have now expected value of x equals to 83.5. So we assign that. So 5,557.5 minus 83.5 multiplied by 64.5. We first multiply following the PEMDAS rule. So we first multiply 83.5 times 64, and then we deduct that to the 25557.5. So we get 171.75. So now, what does 171.75 means? So as you can see here, if we're going to plot our data using x and y coordinate, you can see that our data is going up. So it's like this. So if we will put a line on our graph, so you can see that it's the direction is going up, or the value is going up. Okay, so what does that mean? Okay, so here we can interpret our covariance. So if our data is a positive covariance, since we get 171.5, so that is positive covariance. Our covariance is positive, so that means our covariance is positive, so which validated by our graph of data. So it's like this. It's look like this. Okay. So for if our covariance is negative, we get negative covariance, or the graph will be look like this. Okay. So, and we have also the weak covariance. When our covariance is 0, so we have our weak covariance. Okay, so that's how we interpret relationship between our variables. So we have the positive covariance, negative covariance, and weak covariance. So in the previous example, as you can see, we get a positive covariance. That means the stat1 grade is related to stat2 grade. Okay, so that is covariance. So let's go now to correlation. So what do we mean by correlation? So covariance is interesting because it is a quantitative measurement of the relationship between two variables. However, in correlation, between two random variables. So we have the correlation x and y is the covariance of the two variables normalized by the variance of each variable. So this normalization cancels the units out and normalizes the measure so that it is always in the range of 0 and 1. So we have here the formula for correlation. We have the correlation given x and y is equals to covariance of x and y divided by square root of the variance of x and the variance of y. So correlation measures linearity between x and y. So here we have the previous example. We have our x variable, which is the stat1 grade. We have the y variable, our stat2 grade, and then we have also the x multiplied by y, and then we'll add another since we'll get first the variance of x and the variance of y. So we'll first get the variance of x and the variance of y. So as you can see here, the formula to get the variance of x is equals to expected value of x squared minus expected value of x squared. Okay, so first we're going to get the expected value of x squared. Okay, so here we get x squared, so we squared the x, the variable x. So as you can see, 95 times 95, it's 9025, and so forth. Okay, so and then we get its expected value. So we have now 7148.75, or the average of this data, of the average of the x squared data. Okay, so and then we'll now follow the formula. So for our expected value of x squared, we have 7148.75 minus expected value of x squared. Okay, so here we have 83.5. So 83.5 squared. So which is equals to 7148.75 minus 6972.25, which is equals to 176.5. To get also the variance of y, we will follow the formula E, expected value of y squared minus expected value of y squared. Okay, so to get the expected value of y squared, we will first square y variable. So 70 times 70, that's 4,900, and so on and so forth. And then we get the average of our y2. We get the expected value of y squared, which is equals to 4348.75. So we'll now follow the formula. So 4348.75 minus 64.5. Sorry, this is squared. This is squared. Okay, squared is equals to 48.75 minus 4160.25, which is equals to 188.5. So we'll now we can now get the correlation because we have now the var x and the var y. So following the formula of correlation, we have correlation given x and y, which is equals to covariance given x and y. We now know the covariance. It's equal to 171.75 on the previous example. Divide by the square root of var x, which is equals to 176.5, multiplied by the var y, which is 188.5. And then we get 0.94. So that means 0.94 is in near 1, so that means we have a positive correlation. Okay, so as you can see here, we since our correlation is 0.94, it's nearly here, so here. So That means we have we have a nearest perfect positive correlation. Okay, so that means that our x and y variable are correlated. So if the correlation of x and y is equals to 0, we say that x and y are uncorrelated. Okay, so that's this one. If two variables are independent, then their correlation will be 0. However, like with the covariance, it doesn't go the other way. A correlation of 0 does not imply independence. Okay? So that's how you interpret correlation. So that's it for covariance and correlation. I hope you understand this lesson. So um see you next week for our new lesson in statistics. So if you have any question, you can raise it in our group chat. Thank you very much and stay safe. Thank you.